Okay, in 10.4 now we're going to go into a little more detail on hypothesis testing and the different sections that are involved. So the first thing we're going to do is we're going to state the null hypothesis. So we're going to have a parameter, and we'll see we can do this with population means, sample means. We can do it with proportions, so p's. In fact, let's use an example of a p. So at the beginning of this chapter, we talked about the Dow Jones Industrial Average, and we talked about bull versus bear market, and we had some data that said, okay, out of these 1,000 days or whatever it was, we saw that the market was up so many days, and it turned out to be like 51% of the time the market was up. Well, the market is, it can almost be seen like a coin flip in that, 50% of the time it could be up, so things are valued highly, or 50% of the times they could be down, things are devaluing. And so uh, our going in assumption is going to be that the stock market is like a coin flip, and that the parameter P, the proportion of days that are up, is equal to 50%. So half the time it's up, half the time it's down. Now the alternative hypothesis, which we're going to call HA, contains whatever we think it would be if it's not 50-50. So in our case, we might say that we think it's greater, so the percentage of up days is greater than 50, or we might say it's less than 50. But for generically speaking, we're going to say if it's not 50, if it's not 50-50, the null, then it's just our alternative is that it's not that. We don't know what it is, but it's not 50-50. Okay, so then we're going to come up with a model. So we have to decide on what model we're going to use, and I'll just cut to the chase here. In most of the things we do in this class, we're going to go normal model. So again, we have to state our assumptions, check the conditions. So for normal model, we have to make sure that we use randomization, less than 10% of the population in our sample, success failure conditions, so n times p has to be greater than 10 and n times q has to be greater than 10. Independence, so we have to try to ensure that the data we collected they're independent pieces of data, and if all those things check out, then we can run the normal model. And would be even better is if we can get some samples and see how these proportions map on a histogram, and if the histogram looks like a normal curve, well then boy, we've really got it nailed and we can use the normal model. And so we have to state what model we're using, the assumptions that we're going into, the conditions, if they're satisfied or not. And that's really the trick, is being honest about your analyses. And this is where a lot of statistics and the sound bites of media will kind of fail us, in that they don't give us that. They don't tell us their assumptions, the conditions, the model they use. They just tell us percentages, and they just try to connect the dots for us. But to be good statisticians and just good, honest brokers of information, we should advertise all of those things. Okay, and then if we're going to use a proportion like we are in this example with the Dow Jones, we will use p-value, p-hats for proportions, and we will use one proportion z-test with z-scores and standard deviations of the p-hat, and we've done these calculations before, and we'll come up with different statistics based on the evidence that we gather. Then the mechanics. So the mechanics can be kind of tricky. This math is not necessarily the easiest to get, and if we're using a normal model, we have tools. We have the tables in the back of the book. Our calculators can actually do this as well, but we have to somehow calculate this, and the calculations would not be easy if you did them by hand. So we want to use those tables or our built-in functions in the calculator, but we want to get a p-value. And as we talked about in the 10.3 video, that p-value is so critical, because that's going to tell us if we're going to reject the null hypothesis or fail to reject it. And again, this is not necessarily an easy number to get at. We'll show you different methods in class how to do it, but that's really the tricky part, is getting that p-value. And once we get it, then it's pretty simple. Then we can make decisions based on it. And then once we basically decide on our parameter, whether it be proportion or mean or something else. Then we decide on the model. and we justify the model we use, then we do the calculations, the mechanics, and then we have our conclusions. And our conclusions are basically going to be if the p, and I can't stress this enough, this is what you want to remember. If the p-value is small, reject the null. So if our p-value is small enough, and we'll decide the threshold, so if it's less than 0.10 or less than 0.05 or less than 0.01, we're going to reject the null, and that means we're going to go with the alternative hypothesis, HA, whatever that might be. But the key thing to remember there is p-value small, reject the null. I can't stress that enough. That's how we're going to remember this. And then in business, it's even more complicated still, because you collect this data, you decide on a model, and then you come up with a conclusion. Well, that conclusion has cost numbers associated with it. So it's going to steer you down a course of action, but that course of action is going to have a monetary value attached to it. And so you may actually do things based on that cost that goes against what your data is telling you. And so it gets even trickier on real business decisions. And the statistical significance comes into play, and we'll talk more about that in later installments of the class. And then the effect size, we'll also talk about that. But these can be, there's a lot to this. So, you hear these statistics thrown around kind of willy-nilly, especially through the media. There is a lot that goes behind good ones to make them good, and we'll talk about that. And that should do it for 10.4.